Hello. So can you all hear me okay? Yeah. Cool. Good start. For those who don't know me, my name is Luke Hook. I'm a senior .NET developer at Jibe Digital. Some of you may have seen this talk before. It's the same talk that we did at Spark. If you did see that talk before and you're here, thanks for the pity, I guess. But also there is differences in here, so there is still new things that you will learn and hopefully find interesting. This talk includes not one, not two, but 3 live demos, all completely reliant on the internet with no discernible backup whatsoever. But there's been no technical issues at all in this room, so everything should be absolutely fine. Today I'm going to be talking about the new HybridCache, and I'll explain the air quotes a little bit later. What it is, how you might use it, when you might use it, alternatives you might use, and everything else. So does that sound good? Yeah. Cool. But before we do that, we're going to play a little bit of a game to break the ice and to test your Pokemon knowledge. Who's that Pokemon? Jigglypuff? That's Steve Temple. Obviously. Next one, who's that? It's Steve Temple. Obviously. Lastly? It's Pikachu, obviously. What are we talking about? Clearly. Okay, so moving on swiftly as Elian. The problem we've got is, so the problem that we're trying to solve, it's not a new problem. In any web application that you have, there's certain things that you're reliant on. Usually there'll be a database perhaps, or a third-party service maybe. And some of those things can cause issues as your application grows, as the database grows, that kind of thing. Data retrieval can be expensive. If you've got a lot of data and you're pulling it in, and over time your database grows. I know as working in a digital agency, we've got sports clients that started off with maybe like 50,000 news articles, and before you know it, that's 300,000 news articles, and suddenly things don't work the same. So the costs for that can rack up. The response times of those are typically slow. Getting things out of the database is quite slow. Getting things from third-party services can be slow. The internet can be unreliable sometimes. Hopefully not today. You get issues with scalability. When you have an application that you're hoping will get more popular, you don't want to be worrying about it being more popular. You want to be comfortable that your application is going to be performing however big it gets and not negatively impacted by the growth. And an over-reliance on the stability and availability of other platforms or other sources is a point of contention that could trip you up quite easily. So we typically use caching, and there's various different types of caching, but we're going to talk about kind of server-side caching today. The benefits of doing so is you get much more improved performance. We'll go into it a little bit later, but you reduce the latency by accessing data from where your application is running on the server rather than the database or necessarily a third-party service maybe. You can reduce the load, the number of database queries, for example. You can kind of knock that out a little bit by serving it from a cache instead. In certain configurations, it helps you with scalability, so whether that's scaling up or scaling out. If you have load balance things, you can help mitigate those things using a cache. And they might be more cost efficient if you have to worry less about bandwidth, going to a SQL server or something like that maybe, or the frequency of the database usage, or even the size of that data as well. It can help with that as well. And it will add resiliency to your application. So you can have multiple layers of caching and then a database source that gives you kind of extra reliability. So we talk about .NET server-side caching. We typically talk about 2 things. We talk about local cache, or more frequently in the .NET world, we talk about memory cache. So that's in-memory storage from the server itself. So that's where your application lives anyway. It's getting information out. We can store, data in there. We can get information out of there. It's very, very high performant. Memory is very, very quick. It's quite simple to implement. It's very good for single server usage because that's where the application lives. But you have limited options, or it's much harder when it comes to scalability. It's not so bad when you're scaling up because the memory can scale with it. But scaling out, you start to get a bit more complex because you're managing caches across multiple nodes. So in those instances, we tend to talk about something like a distributed cache. And some of these terms might be quite familiar. These are obviously things that we use quite a lot. You have a shared cache that's accessed across multiple nodes, or from multiple nodes. Easier to scale as you need to farm out more nodes. That's fine. You've got a distributed cache. It doesn't matter how many are accessing it. This is an important one. Data persists beyond application restarts. So one of the caveats of memory cache is once that application restarts or the app recycles, the memory cache is cleansed, or it's wiped. So it has to be repopulated. And that can happen. A distributed cache is isolated from the server, so it doesn't have that. But it's not as fast, and you're still looking at a single point of failure. So ideally, you want to use a hybrid of... That's a real Pokemon, by the way. Weird. Anyway, sorry. Hybrid cache. Ideally, you want to... Yeah, what are we talking about? The hybrid cache, you ideally want to use a combination of both. So you want to have memory cache to serve the data as quickly as possible, but you want the reliability that you get from and the scalability that you get from a distributed cache as well. So by using a hybrid approach, it ensures that applications can benefit from the low latency of memory cache while maintaining the data consistency and availability through external solutions. So a hybrid cache combines both approaches in a single managed set of APIs. Typically before, if you wanted to manage these things, you'd access a memory cache, and I'll show some of this later, and then you'd also have to manage manually, separately, dealing with the distributed cache as well, and how those things are handled, how they talk to each other, everything else. Hybrid cache looks to consolidate those things, because we're basically doing the same thing, just in two different methods or places, into one single set of APIs. And there's some other benefits of doing that as well. So who is the hybrid cache? Hold on a minute. Excuse me. Hybrid cache is a new caching system introduced by Microsoft in .NET 9-ish. It's not part of .NET 9. It's actually a NuGet package as an extension. You can just download it into any kind of .NET package. But it was released in preview, at least, alongside .NET 9, which is kind of why we talk about there. Hybrid cache itself is an abstract class, and Microsoft supply a default implementation of that class that handles the basic aspects of saving to and retrieving from cache, with some other features as well, which we'll talk about, which is a slightly different approach. It's something that I'll mention a bit later as well. From Microsoft, typically we're used to Microsoft going, oh, that thing in the community looks great. We're just going to completely steal that for ourselves, and we're going to make it ours, and we're going to call it Microsoft and kill off everything else. This is a slightly different approach. By supplying an abstract class means that other open source projects or whatever can build upon that class and then have a predictable set that people familiar can use. But yeah, the concept of hybrid cache itself isn't new. The concept of dealing with a cache in memory and distributed isn't new. Managing those things simpler kind of is. Hybrid cache is available right now. It's now publicly available, full release. As mentioned, it's a .NET extension library. You can download that from NuGet and just plug it into your existing projects or new projects. And there are other third-party hybrid cache solutions available, some more mature even, some with more feature sets, and we're going to talk about that a little bit later as well. But we're going to do a live demo first. Apologies for the cringe. Okay, so first of all, let's look here. So this is, hopefully you can all see that largely okay. So this is just a basic .NET project, very, very, very basic. This is just the program CS setup. We also have here, we have what's called a Pokemon service, I've called here. And all that does is an API endpoint that's going to take a name of a Pokemon. It's going to call the PokeAPI, which is just a free open source API that you can use. There's a NuGet package for that. And it's going to return some data. Really, really simple. But I don't want to hit that every single time. I don't want to hit that endpoint. I don't want to be reliant on that endpoint being up. The data's not going to change very frequently, as far as I'm aware. So what would we usually do? So we can cache that data. That's brilliant. So typically speaking, you'd probably have this in its own isolated service, but you'd have in our program CS here, we add our memory cache, so that we're registering that in our DI container. And in this instance, we've got Redis, which I should open in prep for the talk, which is our distributed cache. So our memory cache is handled. It will read from there first, and then it would fall back to our Redis instance, and then ultimately fall back to our factory, which would be our API endpoint. So real simple kind of stuff. And how that works typically is you then set up the iMemory cache and an iDistributed cache in your constructor, perhaps, or again in a service. And then you'd kind of use the memory cache, you'd go get or create, so it's going to go and look for it. If it can't find it in the cache, it's then going to, we all kind of get how that works, or maybe we don't, that's why we're here. And then to do the distributed cache, you're ultimately doing basically the same thing twice, because you're doing it in a different place. You might have some different config and stuff. And we don't want any of that, because it's now much easier for us to use our hybrid cache. So if we go back to our program CS here, remember regions? Anyone ever use regions? Great for demos. Rubbish over here. Oh, someone does. Thank you. Yeah, they're great. Hybrid cache. Yeah, so we just add it like this. So we've already registered. We still need to register our memory cache and our distributed cache. And then just by adding this NuGet package, our extensions caching hybrid, we can then register in our services collection and add hybrid cache. And that's going to automatically pick up our memory cache as our L1 and our distributed cache as our L2. We've got some configuration options we're going to do here. In this instance, we're going to expire in the distributed cache in 30 seconds, and we're going to keep it in the local cache for 15 seconds. So straight away, we've just added our hybrid cache container there, and then in our services, we inject in a very similar way. We've got our hybrid cache, we inject it into our constructor, and then we just do our cache, get or create async. Exactly the same call as the memory cache one, you'll note, but that's going to manage that completely on its own, automatically, and manage the conditions between both of them using those settings in the program CS. So that's going to manage it into the memory cache with the expiration we've given it. It's also going to manage it in Redis in this instance, all through one centralized API, which is just much neater and easier for us to manage. So if we pray and we click play, we should see very shortly. Cool, that's a good start. So we have our little website here. If I put in Pikachu, so you should see we get a response, he hopes. There we go. Really slow, so that's how I know it went from there, because it used the internet. And there's our little Pikachu, type, whatever, some information. Subsequent clicks of this, much quicker, 3 milliseconds, because we're coming from the memory cache. And if we have a look in our Redis instance, and I refresh this, there's our entry. And it is now going to expire in 15 seconds, but it was there for 30 seconds. And we've got some data in there as well. So that in itself is, just a really quick example of how you would use the new hybrid cache to do what we kind of already do, just in a neater package. And you can change different options. There's lots of different entry options and stuff you can do, but it gives you the basics really simply to allow you to do confident caching. So when that memory cache expires after 15 seconds, it will fall back to the Redis cache. Once the Redis cache expires, it will fall back to source, repopulate, etc., etc. So really good. And you can add different entry options on a per usage basis. So we've set some kind of general top-level ones of what we want to set when we create the service itself. But you can override those options wherever you want to use it, because obviously different places you're using it, the different lengths of time perhaps that you want to cache for in different places. And it doesn't have to be used with an L1 and an L2, which is a memory cache and a distributed cache. You could just set up hybrid cache with the memory cache, and it will still manage that properly, and you'll get some of the other benefits alongside it, which is why you would necessarily want to do it rather than just using the memory cache. So that's just a basic example of how we would use the default Microsoft implementation. But as mentioned, there's some other benefits that you get from using the hybrid cache as well. So you get stampede protection. So what that means is that's going to automatically prevent multiple factories running at the same time for the same key. You don't need to do anything, it will manage that automatically. So what I mean by that is, if, let's say, you have a massive application that's getting thousands of requests a second for the same kind of things, typically what would happen is if you're running from a database, say, or our third party here, once our cache has expired, 1,000 concurrent sessions could hit your database at the same time, all asking for the same thing. to get it, cache it, move on. Stampede protection just eliminates that. It just smartly configures what are my concurrent connections, condenses down to basically one, allows one through to the source, caches that, returns to the others the source. So that's a really good way of just preventing any kind of overload from cache expiry. If we were talking about memory cache, site restarts, that kind of stuff, it handles that for us. And you can see an example of that here. So we might have two products. We've got multiple requests coming in at the same time to the service. The cache is going to condense those to one single request, get them from the source, in this instance the database, and then return them. It's worth noting as well, if in a multi-node scenario, let's say you're load balanced over, 10 servers, it's going to do that per node. So if each node gets 100 requests, they're going to be condensed to one, so you let through 10 requests. That still loads better than what you were looking at before, the 100,000, 10,000, whatever. Maths, hard. As I mentioned, the secondary cache, the distributed cache, is optional. HybridCache works. You get all of these other benefits, whether you're just using memory cache, but if you want to add that distributed cache, it will automatically handle any of that for you. You just have to configure it, and it will kind of do the magic. Tagging, excuse me. So you can group entries via multiple tags. The Microsoft implementation supports this as well, and I'm going to showcase it a little bit later. Entries can then be invalidated by tag in such a way that doesn't impact performance. And I'm going to show what I mean by that in a later demo. But it's a smart way, because what you don't want to happen, if you think that you may have 100,000 nodes, perhaps, millions even, nodes in your cache, if you want to, and they're all tagged as, let's say, content in the example of Umbraco, and you want to purge all of the content from your distributed cache, that could be a really expensive operation to do 100,000 delete operations from that. Whereas it does this in a very special way, which I'll show you a bit later. It's really smart. Multi-node notifications. So again, where you've got distributed nodes, another thing with memory cache, you've got to kind of have a way, Umbraco used to do this with notification handlers maybe, or something similar, of telling all your other nodes that the cache has expired as well, or that a cache entry has been updated in one. It will handle all of that for you. It detects all the other nodes that are connected, and it will handle the notifications between them. And serialization options as well. So typically, you kind of, by default, I believe it uses system text JSON, I think, to serialize and then put them into your cache, but you can extend that with other serializers as well, such as protobuf or message pack or something like that. So you have full customization, and you can write your own serializers as well, and you can kind of handle how that data is stored or in what format it's stored. Cool. So I'm going to do a little bit of a segue here, just briefly. So Codegarden, hands up if any of you have been to Codegarden before. A few faces. Some I apologize to publicly because I embarrassed myself a lot this year when I went. But everything was fine. And what I meant to say is Codegarden is great. It's a really, really lovely place to go in the north of England. Beautiful setup, beautiful place. Great place to meet new people. If you're considering it in any way, shape or form, I really, really do suggest you go for it. It's brilliant. Applications for this year close on the 10th of July. But it was brilliant. And one of the reasons why I'm mentioning that and why it was brilliant is I was introduced by Richard Ockerby. Is he here? Somewhere? Anyway, Rich introduced me to Fusion Cache, which is not something I'd ever heard of. And this is the thing with Codegarden. You get into discussions with lots of people, and people are using all these things. Because as devs, I'm certainly guilty of using things and assuming everyone else must be using this thing. I must be the last person who's heard about using this thing. It turns out that's not the case. People are using stuff, and unless you share about it, you don't know. So it was great to hear about Fusion Cache, which is something that they had been using, and lots of people use for their as a way of hybrid caching. It basically does a similar thing. And I was really intrigued with that. In fact, when I looked it up, I was kind of blown away by how it worked and all of the options that it offers. So we're going to take a look at Fusion Cache, what that does differently than HybridCache, how it can be used as a hybrid cache officially, and kind of the benefits and why you might want to consider using something like that instead of the Microsoft implementation. So we have something called adaptive caching. So it's possible to change the entry options in flight instead of at the factory. So typically speaking, you get your data from the factory and you put it in the way that you get it. But we can cache differently with different options depending on how the state of that data. So if you look at an example here, for instance, so this is using an example of a product. I like to think of this more in the mindset of like a blog post, for example, or something like that. We can see like the last updated date, perhaps, of like this item. And if it's something that's been updated recently, we might want that cache duration to be much shorter because we might want to be, updating that cache instance much more regularly for something that's frequently changed. Whereas if you think that's an article, we have like sports clients and they've got news articles going back years. Nobody ever really looks at them that often. So they can be cached for a long period of time if we cache them at all. So, perhaps a month or a year even, or whatever it might be. So this allows you to kind of intercept that object coming in, check some parameters of it, and change your caching behavior based on what comes back from that. Conditional refresh, weirdly suggested Pokemon there, strange things. Update and refresh cache entries only if there are other modifications or conditions are met. So we can also check in on the factory. We can check the etag values, see if that's changed, which is kind of like a serialization of it. We can check whether there's any differences in it, and maybe we'll just serve a stale entry instead of bothering to go and update it because it's exactly the same as the entry we've already got. We don't necessarily need to refresh. We can return a stale value. And auto recovery as well. So Fusion Cache, this one is a bit like magic. I have no idea how it works, but it kind of will kind of handle little things like transient errors. It has auto retry policies and things that you can tweak with that as well. So if there are smaller, minor issues, which always happens in kind of net concurrency stuff, it will automatically try again and work out where it needs to kind of do those things in order to automatically. You don't have to make any additional configuration to turn that on. Cool. So there's a couple of other features that I think are really powerful that I'm going to show you here today with Fusion Cache. So back to our demo, and our Redis instance should be empty now. Lovely. So get away, done with you. Fusion Cache here instead. Excuse me. So set up in a similar way. So we've registered our memory cache. Now using this package from NuGet, which is the Ziggy Creatures caching Fusion Cache package. So many times I can say cache. We're setting up in a similar way. We've registered the memory cache, so it's going to pick that up. Now we're adding a Fusion Cache, and we're going to add some options. These are similar to the ones we saw before. So you've got the duration of the local cache, the duration of the distributed cache. I'll go through these bits in a minute. And then I've added our distributed cache down here as well. And this tiny little bit at the end here is what will allow you to use that Microsoft abstract class. So just by calling as HybridCache, it will allow it to inherit that. So if, let's say you had a project maybe in the future or whatever, that's using, or maybe by start you just kind of want the basics to get going, you can start with the Microsoft HybridCache implementation, and then if you want further configuration down the line, you can install Fusion Cache if you want to, and you just add the HybridCache, and you don't really need to change any of the other calls in your code that are doing the getting and setting, because it's all pulling off the same abstract class. So really, really nice. And not exclusively, you can still use an iFusion Cache implementation manually anyway. It just gives you that extra option of the HybridCache there. So eager refresh is the one I'm going to talk about here first. So typically what happens with any kind of cache things, you're caching them for X amount of time, in this instance 15 seconds and 30 seconds. You wait for that cache to expire, then it goes in the next request, it will go to the factory, and it repopulates the cache. But we don't need the user or whoever to have that one factory request that is slow in order to repopulate the data. We should be able to predictively go ahead of time and update that data before. So what eager cache does, and why it's a floating point value, is that is a percentage of the duration, after which it's going to, in a background task, go and refresh that cache entry. So 0.5 here is our 50% of our duration. So if I'm going to put this to 30 just for posterity and so I can understand it. So when we run this, our cache duration is 30 seconds. But after 15 seconds, we're still going to return the entry to the cache to the user, but in a background thread, we're actually going to go to the factory and repopulate that memory cache so that and re-extend that duration. So we should, fingers crossed, be able to see that running here. So what I'm going to do for this one, we've just got some more settings here. I'm going to put a breakpoint on the factory here. I am going to put a breakpoint on the factory here. If I knew how to use Visual Studio, it's not my job. OK, so let's go for Pikachu again here. We're going to submit. OK, so we're hitting our factory. That's for the first request. Definitely didn't want airplane mode on. That's the wrong button to have. OK, we're going to step through. I've probably broken it now. Apologies. OK, so that should. Yeah, messed that up. My bad. 2 seconds. OK, so we got a response back in the end. Very long time, because I'm an idiot. So we got our response from the factory there. Subsequent requests are now going to hit it again, because I want to show this properly. OK, so we're going to go off. We're going to hit it. Our Redis cache should have an entry in there. OK, so requests, if I do this quick enough, are now going to come back from the cache, 15. We haven't hit our breakpoint. After 15 seconds here, so now we can hit this again. We've hit our factory. And if we play on there, the response still took 15 milliseconds. It still served the response from the memory cache, but in a background thread, it's gone and refreshed that in memory. So we're not waiting on, or a user doesn't have experience, a slow request going to the source in order to then populate the data. So yeah, really good. And then the next thing, the other thing that's really good, I think, with Fusion Cache is a failsafe. So what a failsafe does, I promise you I do know how to use it. So a failsafe will, basically, we can keep a cache entry. What we might want to do is say we have a duration of 30 seconds for our cache entry. But if there's a problem with our factory, if something goes wrong when we try and retrieve it, we're actually OK. What we'd rather than just break or error or not return anything because there's no longer anything on our cache, what we'd actually quite be happy to do is serve a stale entry. So maybe we want to keep an entry around for a longer period of time so that if something goes wrong, we would rather return something that's slightly out of date than nothing at all, or than to see an error here. So this one's a bit simpler to demo, thankfully. So if I load this up, OK, we're going to do the same thing here. We're going to look for our Pikachu. We should hit our endpoint. We're going to avoid the airplane mode button at all costs. And then we get our response. Now, in our Redis here, we've now got a time of 1 hour. But the actual expiry time of the value that we'll use for our cache is the logical expiry time, and that's set to our 30 seconds. But it's going to keep the key around in our distributed cache and our memory cache for a longer period of time. It won't necessarily use it after 30 seconds. It will prefer to get an updated one from the factory. But if something goes wrong with that factory, it's going to fall back to our stale value, which is really good. It's a much better way for us, in certain instances at least, of serving like a stale value, at least serving something than getting errors back. Especially when you're dealing with third-party services that you're not in control of whether they're up or they're down. They might be unavailable or whatever. And one last thing that I was going to show here, that I was going to showcase, is the tagging stuff. So I'm going to tag Pikachu here as electric. I'm going to submit that. And then in our cache entry here, we should have, let's delete it, do that again. OK. That's not what that's supposed to do. Thank you. OK. So here's our Pikachu, and he should have, he doesn't, oh, I know why, because I'm an idiot. That's something slightly different, which has made this more confusing for everybody, which is useful. Yeah, we've got our tags away, we've added it. I'm going to take this breakpoint off because I don't need to hit it anymore. We'll try that again. Anyway, what I'm hoping this will do, and I can show you anyway, is we'll add tags to the cache entry, which we can then invalidate, and I can show you some of that invalidation. But either way, I can talk you through how that works if this doesn't. I'm going to talk you through how it works. So what I was saying earlier is we can go through and we can categorize things using tags. So again, I used the example earlier, or in this example, we're talking types. In Umbraco's example, it might be content, it might be media, it could be anything else. And sometimes, if you've been in Umbraco, for example, and you've cleared the magic YOLO clear memory cache button and hope for the best if something goes wrong, you kind of want to invalidate all of those those tagged entries based on that cache. And again, that operation could be really expensive if you've got hundreds of thousands of nodes. And what happens here instead is it will actually put a new entry in, which will be a marker tag for that tag itself. So let's say content, or let's say the electric type in this instance here. And then rather than when a request is made for that Pokemon, it will have a look and say, okay, well, I've got a cache entry here that says if there's we need to expire anything that's of the electric type. And that will basically say, okay, cool, return that back, go to the factory and get the new one. Don't use this entry, it's already in there. So those will naturally expire and move off. They're now redundant, essentially. But that way, rather than having 100,000 delete requests that could be expensive and take a long time, all we're doing is adding one marker key in that tells it that anything with that tag has expired. So it's a much more efficient way of it working through those changes. So that's the Fusion Cache one. So let me go back to the slides. So yeah, lots of good changes, lots of configurable options, and there's other things with Fusion Cache as well. There's things called backplanes, and there's some other bits as well that I can show you on their website. But I recommend going and looking at their docs. Some of the best docs I've ever seen written, frankly. I'm not massively technical, and it does a really good job of dumbing that down, which I need. But it also really extensive feature base. So if you're looking for the kind of basics and you want to use something like a hybrid cache, the Microsoft implementation is a good start. If you want more configuration and configurable options and advanced options, Fusion Cache is excellent, and I really recommend it. And it's easy to start with one and swap it out for the other because you can base off that abstract class. And both HybridCache and Fusion Cache work with versions of .NET all the way back to Framework 4.7.2. And if you're using anything before 4.7.2, then I'm sorry. But this is Codegarden, so I should probably talk a bit more about Umbraco at some point. Umbraco's been using since v15. Umbraco's already been using the hybrid cache implementation for the document cache. So it uses it for caching your media and your content, and it does a kind of lazy loading approach to that, using some of those basic features, using the default hybrid cache implementation there. So you can see here, this is from the Umbraco source code, for example. You can see where they've configured the Umbraco hybrid cache, and they've kind of set up a custom serializer and some basic options. And they also, I can show you here. You can see, so in the docs, you have configurable hybrid cache settings for the local cache duration. For media and documents, same with the remote cache duration, and you can see how they map to the options that we were setting here. So these are exactly the same hybrid cache entry options. They actually map to the expiration and local cache expiration. So Umbraco's already using that, which is great. In fact, Emma and Lottie did a talk at .NET Conf earlier this year, or maybe last year. Last year, I guess, 2024, makes sense. Introducing this and talking about how they decided to go with this Umbraco cache. And as you can see, so they already used that for their document cache anyway, and they chose to roll with it in even though it was in early preview. So one last quick thing to talk about. We've talked about this already. If Umbraco is already using the hybrid cache, the Microsoft abstract class, we can potentially swap out to a Fusion cache really easily and take advantage of those additional features, the eager refresh or what, for example. So, one last time, I promise, last demo. We've got another project here. This is an Umbraco v16 solution, so fresh out the box. And by default here, it's just the default program CS that we've got. And this line I'll show you first of all. So this is just going out and stripping out, first of all, the hybrid cache that it's already using, the Microsoft implementation. So if we run this, we should hit an error, because it should tell us off that the document caching service won't work, basically, because it doesn't have a hybrid cache there to use. So we'll let that spin up just a sec, and we'll clear this out. Yeah, good. Because what we want to do, we want to strip out the hybrid cache one, and then we want to add our Fusion cache with that as hybrid cache option, which would register it for use as the document service. So as you can see here, yeah, it's looking for a hybrid cache. It can't find one. It's trying to do the document caching service. That doesn't work. All good. That's expected. So we can swap in our Fusion cache instead. So we're adding Fusion cache. I've just added some size parameters, which matches the stuff that Umbraco was using in the docs for theirs. I've got our basic serializer, and we're using our Redis instance. So if we load this up, so now this should load up our Umbraco instance, and we should see in Redis that we're now using Fusion cache instead. Private joke for anyone that saw this at Spark. Again, apologies, but all good. So, and we should now see in Redis, yeah, we've got our document cache in there, and that's adhering to our values that we've set in the config. So really easy. That took 2 seconds for it to work out what we were doing, and to swap out, sorry, the Umbraco cache to use Fusion cache instead. So really easy settings. And again, what we talked about there is, can we use some of those more advanced features then to do something a bit more special? So I'm going to add the eager refresh again with 0.5, so that's 50% of our duration. I'm going to set this to 1 minute, just for demo purposes. Don't recommend doing that in production, because that will cause problems. So if we run this now, no. Better. Okay, so when this boots up this time, we should see, and I remove our key from Redis. And this is a good way of showing this, actually. If we go to Umbraco, password 123, and a smiley Nurak. So if we go to our magic button here, and we reload our memory cache, and then we refresh Redis. So there's a couple of things to note here. Here's our entry, first of all. It's now got an expiry of 1 minute, because that's what we set. And these are those tag markers that I talked about. So rather than deleting all of our content entries, like I said, if you've got loads, it actually adds a small Fusion cache tag content node. So that's telling it that if there's any requests for content, anything tagged as content, ignore them for now, go and get them again from the source, because we've got a tag removal there. So, so all requests to the front end will be coming from the cache. But in our, once we hit under 30 seconds, which I think we already have because we've refreshed, what's expected is under 30 seconds, we're going to still return that from the cache, but it's going to go and update that key and refresh it in the background ahead of time, rather than waiting for the keys to expire and doing it that way. So yeah, in a couple of seconds here, we should just be able to refresh the page, and then we should see this key be refreshed. So refresh, he says. Do this, yeah. And it's refreshed that ahead of time, right? So after half the duration. So you can see how that kind of process works. So really easy to swap out, for example, Umbraco document cache, which you can use for everything else as well if you needed to, with Fusion cache to get more advanced caching options for documents or anything else. There's some caveats and warnings with that, of course. That's not an officially supported feature, obviously. HQ aren't going to go ahead and sort of explain to you necessarily in the docs anything, but how you use Fusion cache or the extra settings that you can use with Fusion cache. So just be aware of what doing some of those extra features might do. They might need a bit more testing. Serialization, so I've actually got an example here where I was playing with it, because Umbraco do some slightly different serialization for some more advanced doc types. So there is, technically speaking, a custom serializer that I've written here for MessagePack that will kind of go in and it will map things properly so they serialize and come out the right way. So that's something to be aware of that you might need to do if you're using it, if you're using MessagePack as your serializer even. Obviously, that adds complexity. If new people are coming on to a project, it's using something maybe that they don't expect, settings that they don't expect. You're not going to go and find in the docs what's happening, so just be aware of that. And it's up to judgment how impactful those benefits are. It might be fine with doing the kind of basics anyway, or you'd kind of get ahead of that. Yeah, and ongoing maintenance, it's up to the onus is then on you, not HQ, to keep up the changes to any caching stuff if you want to make changes to those settings going forward. So just some things to be aware of. So there's a couple of links there as well, some more useful than others, but generally speaking, just Googling HybridCache will get you where you want to know. Highly recommend having a look at Fusion Cache if any of this talk has been useful for you at all. Really easy to implement, as you've seen, much more advanced operations and features. And some of the best documentations for a project I've seen in a long time. And the guy who maintains it, a guy called Jody, really, really super nice guy. I've spoken to him a couple of times, just raised issues or asked questions. Really, really impressive stuff. And that's a link as well if you wanted to see the video from Lottie and Emma about how Umbraco went ahead and used that as well. So that's the end of the talk today. You can find me on LinkedIn if you want. It's Luke Hook, and my website is Luke Hook, and my blue sky is Luke Hook. And if you weren't sure of my name, my email is luke.hook. Feel free to give me a shout if you've got any questions. But yeah, hopefully you learned something today. Thank you very much for your time.